Hi all, today I am going to discuss about addition of two vectors. So while we are adding two vectors, we have to follow either of these rules. So there are three rules. First law is triangle's law, second is parallelogram's law, third is polygon's law. So now I am going to discuss about triangle's law. So this is very easy. Let us consider two vectors, A vector and B vector are acting at this point. For example, if you take an example of an ant. Let's say A ant is dragging a paddy seed along this direction and B ant is dragging that paddy seed along this direction, and angle between these two ants or their applied force between the two applied force of the two ants is, let's say, theta. So without changing these two vectors both in magnitude and direction, I am shifting A vector to this and I am shifting B vector to this. So my A vector is now PQ and B vector is now QS. So PS is the third side of the triangle which will give me the resultant. So what will be the law? If two vectors are represented by the two sides of a triangle, all taken in same order, this word is very, very important, then their third side taken in opposite order will give the resultant. So this is in opposite order with A vector and B vector. So from this I can write R vector equal to A vector plus B vector. Once again I am repeating it. Remembering the statement is less important than understanding the concept. So try to understand, because there are so many statements in various books. So if I represent two vectors by the two sides of a triangle, all taken in same order. What do you mean by same order? Same order means one vector finishes, another vector starts. One's head is attached with another's tail. Head, tail. So same order may be like this, So one's head, another's tail. This is same order. What do you mean by opposite order? Either two vector possess same tail at one point, or two vector possess head at one point, common head at one point. Here R vector and A vector possess common point at their tail region. That's why R vector is opposite order with A vector. Here R vector and B vector are possessing a common point at their head region. That's why R vector and B vector are in opposite order. Whereas A vector and B vector are in same order, because A vector finishes, B vector starts. So when two vectors are represented by two sides of a triangle, all taken in same order, then their third side of the triangle will represent the resultant of the two vectors. Now resultant R equal to A vector plus B vector. So at least we know how to add two vectors. But what is the magnitude and what is the direction? That I will discuss now.
2, 3, start.
So here I have already represented A vector and B vector through this triangle PQS. Now let us consider PQ is A, magnitude of PQ is A, magnitude of QS is B, PQ is A, QS is B, and PS is R. So now theta is angle between A vector and B vector. There is a trick. Everyone are making mistakes. This is not the angle between A vector and B vector. This side is always angle between A vector and B vector. So how to make an angle between two vectors? Just go to their tail regions. So what I did here, this is my A vector. I am just shifting this A vector to this, so that both tail of A vector and tail of B vector will lie here, so that I can create an angle. So remember, angle between two vectors is always considered from their tails, not from their head and tail. So this should not be the angle. This is always the angle. So theta is angle between A vector and B vector. You can make two lines parallel like this. So this will be theta, this will be theta. So theta is angle between A vector and B vector. I am writing here. Theta is angle between A vector and B vector. And beta is the angle between R vector and A vector. I am writing angle between r vector and a vector. After some time we will see what is beta and what is its significance. Okay, now let's go to the equation. Already I have mentioned, that is r vector equal to a vector plus b vector. Now I will choose, very simple, just recollect the idea from Pythagoras theorem. So using Pythagoras theorem in this triangle, so you are watching two right angle triangle PTS and QTS. So first you take in triangle PTS, using Pythagoras theorem, PS square equal to PT square plus TS square. For your convenience, I am zooming this picture. So this is my P, this is my T, this is my S. So PS square equal to PT square plus TS square. So what I can write? I can write PT equal to PQ plus QT. PQ plus QT whole square plus TS square. So I keep on solving. So what I'll do? I use A plus B whole square formula. This is PQ square plus 2PQ into QT plus QT square plus TS square. So I got PS square equal to PQ square plus 2PQ into QT plus QT square plus TS square. So now I know PQ is A and PS is R. So just put the values. R square equal to, for PQ you can put A square plus 2 into, for PQ you can put A. Let's consider another diagram. I have zoomed this SQT triangle here for your convenience. Okay, so if I zoom this SQT triangle here, SQ is B and this is theta. I have dropped a perpendicular ST on PT. I repeat, I have dropped a perpendicular ST on PT. So this is my hypotenuse H, this is my base B, this is my perpendicular. If you watch my previous vector videos, in rectangular components of vectors or representing a vector using unit vectors, so you can easily understand that if this is B and this is theta, the side which is attached to theta will be always B cos theta. This magnitude is B, this is B cos theta, and the side which is not attached to theta will be B sin theta. I have just used it. So here if you look at this equation, PQ square A square 2PQA, for QT just go to this diagram. QT is your B cos theta. So for QT this will be B cos theta plus, now let's consider this QT square plus TS square. Again I am coming to this triangle. Here if I apply Pythagoras theorem, QS square will be QT square plus TS square. Just use Pythagoras theorem in the small right angle triangle QTS. In triangle QTS, QS square equal to QT square plus ST square. So what is your QT square? Already I have mentioned, that will be B square cos square theta plus, what is your TS square? That will be B square sin square theta. Now if I take B square common, it will be cos square theta plus sin square theta. And you know cos square theta plus sin square theta is 1. Cos square theta plus sin square theta is 1. You know this. Cos square theta plus sin square theta is 1. I am using it here. B square. So my QS square equal to QT square plus TS square equal to B square. So directly I can put QT square plus TS square is B square. So I got a formula, R square equal to A square plus B square plus 2AB cos theta. Now R equal to root over A square plus B square plus 2AB cos theta. So this will give me the magnitude of two vectors or magnitude of resultant of two vectors. Okay. Already I have found out how to add two vectors using a formula, that is R square equal to A square plus B square plus 2AB cos theta. Now, since resultant of two vectors is a vector quantity, we have to assign magnitude as well as direction. Already we have found out the magnitude. Now let us consider the direction. So beta is angle made by r vector with a vector. So I will go to the big right angle triangle PTS. In triangle PTS, tan beta in triangle PTS, tan beta equal to P by B. So this is my perpendicular, this is my base, this is my hypotenuse. So P by B. So P is how much? ST, and B is how much? PT. But you know, ST is nothing but B sin theta. Already I mentioned. So B sin theta. And what is PT? PT is nothing but PQ plus QT. PQ plus QT. So I can write B sin theta by PQ is A and QT is B cos theta. Here QT is B cos theta. I am taking from here QT is B cos theta and ST is B sin theta. Or else I will draw a diagram here. Once more, QST, this is my B, this is my theta, this will be B cos theta, this will be B sin theta. So in small right angle triangle QTS, if this is B, this is theta, this is 90 degree, this is a perpendicular I have drawn in the diagram. So Q2 will be B cos theta, QT, B cos theta, and ST will be B sin theta. ST will be B sin theta. So I got tan beta equal to B sin theta by A plus B cos theta. So beta equal to tan inverse B sin theta by A plus B cos theta. So this will give me the direction of the resultant of two vectors. Beta is the angle made by r vector with any of the two vectors. Here I have considered A vectors. So we got two formula, r equal to a square plus b square plus 2ab cos theta root over, and tan beta equal to b sin theta by a plus b cos theta. Or you can write beta equal to tan inverse b sin theta by a plus b cos theta. So we have got two formula. One is required to find the magnitude of the two vectors, magnitude of the resultant of two vectors. Another one is required to find the direction, because resultant of two vectors is always a vector quantity. So first case 1, when a vector is parallel to b vector, this sign is parallel. So when a vector is parallel to b vector, it means angle between them is 0 degree. Already I have mentioned in my previous videos in types of vectors. So when two vectors are parallel, angle between them is 0 degree. So my resultant will be r equal to a square plus b square plus 2ab cos 0 root over. So cos 0 will be 1. So since cos 0 will be 1, so this will be a square plus b square plus 2ab root over. Now this will be a plus b whole square root over, which is equal to a plus b. So r equal to a plus b. This is maximum value. So when two vectors are acting parallel to a point, the force or the resultant of two vectors is maximum. That is, just directly add two vectors. For example, suppose you are going to a fair and with your father, you and your brother both are dragging your father in one particular direction. Here is your father, you are drawing with a force A, your brother is drawing with a force B, so that your father will move in same direction with a force R. So this is the formula. So directly you can add. So now tan beta equal to b sin theta. B sin, what is your theta? Theta is 0 here. So theta is 0 here and sin 0 is 0. So b sin 0 by a plus b cos 0. You know sin 0 is 0. So 0 by anything, whatever may be there in the denominator, 0 by anything is always 0. So when tan beta is 0, beta will be 0. So beta is angle between r vector and a vector, I mentioned. So here r is along the direction of a vector. So angle between r vector and a vector is 0. So this is first case. So when a vector is antiparallel to b vector, antiparallel means they are opposite to each other in direction, angle between them is 180 degree. So r square equal to a square plus b square plus 2ab cos 180. But you know a square plus b square cos 180 is minus 1. So this will be minus 2ab r square, which is equal to a minus b whole square. This is r square. So r equal to a minus b. And this is the minimum value. So whenever we add two vectors, we will get a maximum value a plus b. We will get a minimum value a minus b. So whenever or wherever you are adding two vectors in whatever may be the way, but its maximum value cannot go beyond a plus b and the minimum value cannot go below a minus b. So basically resultant of any two vectors added anywhere under any conditions will be like this. So this is the real concept of the day. So a minus b is less than equal to r is less than equal to a plus b. Why I am saying, why I am putting a star mark, you will get n number of entrance question on this. We will discuss in later. So r equal to a minus b minimum value. Now I am calculating tan beta b sin 180 by a plus b cos 180. So again sin 180 is 0. So 0 by anything is 0. So basically beta equal to 0. So I can again recite that example. Suppose this is your father. You are dragging with a force A and along right side, and your younger brother is dragging your father towards left with a force B. Since your elder brother, your brother is young, so I am assuming that magnitude of A is greater than magnitude of B. It means your father will move in this direction, but the resultant will be A minus B. And look, R vector is also directed along the direction of A vector. It means they are parallel. Angle between them is 0 degree, which I have mentioned here. Now my third case is when A vector is perpendicular to B vector. This is A vector, this is B vector. Angle between them is 90 degree. So cos 90 will be 0. You know cos 90 is 0 and sin 90 is 1. So I will directly put it r square equal to a square plus b square plus 2ab cos 90, and you know cos 90 is 0. So this will be a square plus b square r square. So r equal to a square plus b square root over, and tan beta equal to b sin 90 by a plus b cos 90. Okay, now sin 90 is 1, cos 90 is 0. So this will be b by a. Tan beta equal to b by a, beta equal to tan inverse b by a. Actually, this case is directly related to Pythagoras theorem. I am just drawing it. This is a vector, this is b vector. Angle between them is 90 degree. If this side is 90, this side is also 90. Now this is my resultant vector r. Look, if this is 90, now if I am writing r vector equal to a plus b, then r will be directly a square plus b square root over from Pythagoras theorem. So this is the third special case of two vectors when added making an angle 90 degree with each other. Means when two vectors are perpendicular to each other or normal to each other. So r equal to a plus b. Now r equal to a square plus b square root over. A square plus b square root over. And if this is the angle, then from the diagram directly you can say tan beta equal to p by b. So this will be b by a. So I think tan beta equal to b by a. So beta equal to tan inverse b by a. Hope you are clear. But the most important thing is, remember this formula. R equal to a square b square 2ab cos theta root over, and beta equal to tan inverse b sin theta by a plus b cos theta. Thank you.